Hello, in this video, we'll be discussing the quadratic formula using discriminant or delta. So generally, we know that the quadratic equation is represented in the form of ax squared plus bx plus c. So using the quadratic formula, x equals minus b plus or minus or square root b squared minus 4ac divided by 2a. You may check the video up here to see how to use the quadratic formula without the need of a discriminant or a delta. So coming back to this, if we are to use a discriminant or delta, so using a discriminant is what is inside the square root. What is inside the square root here is what is referred to as discriminant. So b squared minus 4ac is what is referred to as discriminant. The discriminant is usually represented with a delta or with a capital letter D. Let's represent this quadratic formula with the use of a discriminant. That means x equals minus b plus or minus square root of, instead of writing b squared minus 4ac, we represent it with a delta, and that represents the discriminant divided by 2a. This means the discriminant where the discriminant, which is delta, equals b squared minus 4ac. The reason why we use a discriminant is to determine what the real root of the answer or the solution of the quadratic formula is going to be. So can we determine the solution or can we not determine the solution? That's what a discriminant is meant to show us. So there are three situations. The first situation is if the discriminant delta is greater than 0. If delta is greater than 0, then that means we will have two real roots. So that means when we solve the equation, we are going to have two real roots, which means we are going to have x1 and x2. So we will have two real roots, x1 and x2. The second situation is if the discriminant is equal to 0, that means we will have one real root, which means we will have only one answer. That means x1 will be equal to x2. So the value you get for your x1 will be exactly equal to the value you get for your x2. And the final situation is if delta is less than 0, then we will have no real roots. So there will be no solution to the question, basically. So that is what the discriminant is used to determine. So if the discriminant, when we calculate the discriminant, if we calculate b squared minus 4ac and the answer is greater than 0, we will have two real roots, which means we'll have x1 and x2. If the delta is equal to 0, we will have only one real root, which means the value of x1 and the value of x2 will be equal. And if it is less than 0, there will be no solution. Let's look at three examples, and each example falling in one of the three situations. The first example says, solve minus 2x squared plus 3 equals minus 5x. So step 1 involves, we have to make sure that the equation is in the general form or the standard form. So we have to make sure that the equation looks like ax squared plus bx plus c equals 0. if we're able to write the equation in this form, or if the equation is already in this form, it is easier for us to get the value of a, b, and c and apply the formula correctly. We can see that this equation is given to us as minus 2x squared plus 3 equals minus 5x. Comparing this to this, we can see that the equation is not in the standard form, so we have to rewrite it in the standard form. So this will have to become minus 2x squared. Bring this minus 5x from the right to the left, it will become plus 5x, and then we have plus 3, and we are left with 0 on the right hand side. Now the equation has been rewritten in the general form or the standard form, so it is easier for us to determine the value of a, b, and c, which is step 2. So a equals minus 2, b equals 5, and c equals 3. So a equals minus 2 because a is usually the coefficient of x squared here. A is the coefficient of x squared. And from this equation, we can see that the coefficient of x squared is minus 2. B is the coefficient of x. And we can see that from this equation, the coefficient of x here is 5 plus 5. And c is the value without no x, the constant. And in this question, it is plus 3. Correctly determine the value of a, b, and c is very important. And wherever there is a negative, the negative always belongs to the coefficient. Never ignore the negative. That is very important. Step 3. We need to find the value of delta, or the discriminant. So we know that the discriminant represented with delta equals b squared minus 4ac. So solving, delta will be equal to b squared. B is 5, so that is 5 all square, minus 4. A is negative 2, so negative 2, and c is 3. So delta equals 5 square is 25, minus 4 times minus 2, that will give us 8. 8 times 3 is 24, so we have plus 24. So that means delta equals 25 plus 24, that's 49. Now here we can see that delta is greater than 0 because 49 is greater than 0. So delta is greater than 0. So that means we have 2 real roots. Step 4. We need to find the roots. Find the real roots. So we know that x equals minus b plus or minus square root of delta divided by 2a. X equals minus b. B is 5, so minus b, which is 5, plus or minus square root of delta, and delta is 49, divided by 2a. A is minus 2. So x equals minus 5 plus or minus square root of 49 is 7, divided by 2 times minus 2, that's minus 4. Having reached this situation, we divide the operation of the negative and the positive, and we solve each operation individually. So we have the first x, let's call it x1, the first real root, let's call it x1. That will be minus 5 with a positive operation here. With a positive operation, plus 7 divided by minus 4, and x2 with the negative operation will be equal to minus 5 minus 7 divided by minus 4. So x1 equals minus 5 plus 7, that's 2, divided by minus 4. That means x1 equals minus 1 over 2, or we can simply write it as minus 0.5. x2 equals minus 5 minus 7, that's minus 12, divided by minus 4. So x2 equals negative 12 divided by negative 4. That will give us 3. And the two real roots are minus 0.5 and 3. And that's the solution to this question. A quick recap of what we did. The question says solve minus 2x squared plus 3 equals minus 5x. So the first step involves writing the equation in the standard form. So we have to make sure the equation looks like ax squared plus bx plus c equals 0. That will help us correctly determine the value of a, b, and c. Because correctly determining the value of a, b, and c, it's important for us to be able to find the discriminant. And once we determine the value of the discriminant, we have to check, is the discriminant greater than 0? Or is it less than 0? Or is it equal to 0? When a discriminant is greater than 0, we realize that we're going to have two real roots. Because when we substitute the value of delta into the quadratic formula, and we end up with the positive and negative operation done individually, we'll have two separate answers as we have in this question here. Let's look at another example. Second example says, solve 5x squared minus 10x equals minus 5. The first step involves making sure that the equation is in the general form. So 5x squared minus 10x equals minus 5 is not in the general or is not in the standard form. So rewriting it in the standard form will be 5x squared minus 10x then plus 5 equals 0. Now the equation is in the standard form and we can correctly determine the value of a, b, and c. So that means a is the coefficient of x squared. So that means a equals 5. B is the coefficient of x. So the coefficient of x here is negative 10. It is important that you do not ignore a negative sign. If there is a negative sign, the negative sign belongs to the coefficient. And the value of c equals 5. So finding the discriminant, delta, we know that delta equals b squared minus 4ac. So that means delta will be equal to, b is negative 10. So negative 10 all square minus 4 into the value of a is 5 and the value of c is also 5. So delta equals negative 10 all square is 100 minus 4 times 5, that will give us minus 20. Minus 20 times 5, that will give us minus 100. So delta equals 0. So since delta equals 0, we expect that we have only one real root. That is, we expect that the value of x1 will be exactly equal to the value of x2. Let's check. To find x, we know that x equals minus b plus or minus square root of delta divided by 2a. So applying this formula, x will be equal to minus b. B is negative 10. So we have negative 10. This is why I said earlier that holding the negative is very important. So we have a negative in the formula here. We already have a negative in the formula here. And b in of itself has a negative. So you don't ignore any of the two negatives. That means you're going to have two negatives. Plus or minus square root of delta. The value of delta as we've gotten is 0 divided by 2. The value of a is 5. That means x equals negative 10 is positive 10 plus or minus square root of 0 is 0 divided by 2 times 5 is 10. So separating the positive and negative operation, x1 will be equal to 10 plus 0 divided by 10, and x2 will be equal to 10 minus 0 divided by 10. So the first value of x1 equals 10 plus 0 is 10 divided by 10. So that means the first value of x is 1, and x2 equals 10 minus 0 is 10 divided by 10. So that means the second value of x is 10 divided by 10 is also 1. As we've established earlier, we said since delta is equal to 0, we expect that the value of x1 should be equal to the value of x2. And as we can see, indeed, the value of x1 is equal to the value of x2. Hence, we have only one real root. That is only one real root. In this situation, the real root here is equal to 1. Third example, solve minus x squared plus 6x minus 14 equals 0. First and foremost, we need to determine if the equation given to us is already in the standard form. Looking at it, we can see that it's already in the standard form because it looks like ax squared plus bx plus c equals 0. Hence, we don't need to do any readjustment. So directly, we can determine that the value of a is the coefficient of x squared here. And the coefficient of x squared here is negative 1 minus 1. The value of b is the coefficient of x, which is 6. And the value of c is the value without no x beside it, the constant, which is negative 14. So next we find delta, the discriminant. So we know that the formula for the discriminant is b squared minus 4ac. So delta equals b squared, b is 6. So 6 all square minus 4. The value of a is negative 1 and the value of c is negative 14. So delta equals 6 square is 36 minus 4 times minus 1, that will give us 4, and 4 multiplied by minus 14, that will give us minus 56. So delta equals 36 minus 56, that is minus 20. So since delta is less than 0, we expect that there will be no solution, that is no real roots. And the reason why we won't have any real root is because if we are to apply the formula to find x, which is minus b, plus or minus square root of delta divided by 2a, we will realize that we will have to take square root of delta. And square root of delta will mean we are taking the square root of negative 20. And we can't have a square root of a negative value, so hence why we have no solution. And since the square root of delta has no solution, there is no way for us to use it to find the value of x. One of the possible ways that the question can be given with the use of a discriminant is the question gives you the discriminant and asks you to find a certain value in the question. So you may be given the discriminant and you'll be asked to find the value of A, B, or C. For example, so you may have a question like, if ax squared minus 6x equals minus 1, and the discriminant is 16, so find the value of A. In this kind of question, what you need to do is really simple. Solution. We know that a discriminant, which is represented by delta, is equal to b squared minus 4ac. All we need to do is find the value of A as asked by the question. We can find the value of A by using the formula of the discriminant. Before we can find the value of A, we have to make sure that the equation given to us is in the standard form. So the equation ax squared minus 6x equals minus 1. This equation is not in the standard form. In order to correctly determine the value of A, B, and C to use in the formula of the discriminant, we have to make sure that we are writing the equation in the standard form to avoid any mistake. So rewriting this equation in the standard form, we will have ax squared minus 6x plus 1 equals 0. Now that we have written this equation like this, we can correctly determine the value of A, B, and C. The value of A is unknown. The value of B equals negative 6. Important, do not ignore the negative. And the value of C equals 1. Had we not rewritten this equation in the standard form, we may have made a mistake of writing the value of C as minus 1, which would have been a wrong value. Now that we've correctly determined the values of what we can determine, so let's substitute the values into the formula. We know that delta is given to us in the question is 16. So we write 16 equals b squared. So b is negative 6. So we have negative 6 squared minus 4. We don't know the value of A, but we know the value of C. And we know the value of C is 1. So we have 16 equals negative 6 all square. That will give us 36 minus 4 times A, that's minus 4A, minus 4A times 1, that will still be minus 4A. Now this looks like a simple linear equation. So we'll have 16, bring this 36 to the left side, we'll have negative 36 equals minus 4A. So that means 16 minus 36, that will give us minus 20 equals minus 4A. Dividing both sides by negative 4. So negative 20 divided by negative 4, we are left with positive 5. And negative 4 will cancel negative 4, we are left with A. So that means A equals 5. So that means correctly rewriting this equation, A is 5, so we have 5x squared minus 6x plus 1 equals 0. When you calculate the discriminant of this equation that we have here, you will get that the discriminant is actually equal to 16. So this is one of the possible ways that a question could be given with the use of a discriminant. Hope you found this video helpful. If you do, please leave it a like and subscribe to the channel. Thank you very much for watching. See you in another video.